Hi everyone, my name is Zaya. I am from Singapore. Thank you for watching this video. I'm absolutely thrilled to share with you my project called AskParliamentSG, which is ultimately about empowering the Singaporean voters through generative AI. So this is a project that I've done as part of the Google 5 days intensive generative AI Capstone 2025 Q1. So without further ado, let me just dive right into setting the context. So just last week, an announcement was made to dissolve the Singapore's parliament, and the date of the general election was announced on the 3rd of May. So for those who are unaware, general elections in Singapore happen once every 5 years. So this is a huge thing for Singaporeans to look forward to. So one of the key factors influencing people's decision would be to evaluate the capability of a certain candidate uh, in terms of whether he or she is able to effectively represent their views in Parliament. And after all, it is the fundamental duty of a member of Parliament to be the voice of Singaporeans, raising issues and feedback that they've heard from the ground to Parliament in trying to improve the society overall. So that's essentially what I would say as the one of the factors that would weigh on the minds of people. As elections are drawing nearer, we do also have a need for Singaporeans to have access to some clear, accessible information about their MPs and how they have performed in the current term. This is specifically for the existing MPs, members of Parliament, who have served out the current term. And the current term here refers to the 14th Parliament, which is the term of Parliament for the last 5 years from 2020 till now. These Parliament sittings that happen like maybe several times per month do have the raw transcripts being recorded on a platform called Hansard that looks like this. So you have a website which contains the metadata around the parliamentary sitting, the attendance records, as well as the verbatim information, verbatim discussion that happened within the parliament sessions with respect to various issues. So the thing is, while this presents a very comprehensive repository of information with respect to what happened in parliaments, it is extremely lengthy, and it just takes forever for me to scroll all the way down. And this is only talking about just one single parliament sitting. What we then have are a total of more than 160 parliament sittings over the last 5 years. So there's effectively no way for an ordinary citizen to be able to navigate these 100 over pages to be able to track and understand how the issues have been evolving and what were discussed in Parliament and who said what and whether or not their representative MP did really voice out issues on behalf of the residents. So this lack of information would really be something that I feel hinder decision making. On the flip side, with information about like an MP's effectiveness, what issues an MP has really advocated for, or just having general sense of like government's position on different issues, would be something that would greatly contribute towards an effective decision making on the part of the citizens. So that's essentially the objective that we're trying to achieve here. Essentially, Ask Parliament SG hopes to address these challenges through designing some sort of a QA, question and answering system, that then gives Singaporeans the power to pull the information themselves with regards to various details. So that's really the background and challenges around uh, Singaporeans having to pull information themselves in understanding the performance of MPs and issues. So without further ado, let me just go straight into the technical bits. So we've done some setups and imports right over here. Create a client based on the API key. And first thing first, we load the dataset. Let me just spend a couple moments talking about this dataset. As a prerequisite, we actually scrape the data from the Parliament websites. All 100 over Parliament sittings were web scraped as a prerequisite to this project. And what we see now basically is a data frame that contains 161 rows, representing 161 Parliament sittings since August 2020. So each row here represents the individual Parliament sitting, and the column content contains the raw text that was scraped out from the main page here. So you can imagine it kind of consists of various parts to it. You have the Parliament metadata, you have the attendance records, and then you have the raw transcribed speeches. So that's the first step as a prerequisite in this project that I've done. And then looking at the raw content itself, we can see that it consists of three main sections: the Parliament details, the attendance records, as well as the transcribed speeches. So what we did is a little bit of like data transformation and data cleaning to separate out these three things from the raw content, and then also some data cleaning to, for example, remove duplicates. So that's done. What I was envisioning in my mind was to use LLM to help me in pulling out structured information from here, basically the parliamentary details as well as the MP's attendance records. So that's on from the Parliament details and attendance columns, and examples of which are shown over here. This is the Parliament details. So my goal was really to pull out information like Parliament number, sitting date, sitting number, etc. And then on the MP attendance records, we are interested to pull out the names of the MPs, the constituency names, meaning the constituency where they represent, as well as the role of a particular MP. So, for example, is he a Minister of Trade? Is he a Speaker of Parliament? Is he a Parliamentary Secretary, for example? So that's the goal here in using structured output. So this is an excellent use case for me to play around with structured outputs using LLMs. To do so effectively, I'm using a data model approach with the PyDentic package. And really what I aim to do here is to define a fixed schema of JSON output that we would like the LLM to pass to adhere to in the passing out from the unstructured text. So things like Parliament details, I want it to pass out the following information, and then for member information, I want it to pass out like the name, constituency, and role. And then I just pass this definition of the structured output. Sorry, I just passed this JSON schema into my LLM, and that is the way I define a fixed schema for structured output. So the first round of exploration is using zero shot, meaning we don't need to explicitly guide the LLM. We just let it do the job with the schema definition and see how well it performs. So here, That's what we have done to uh, kind of assess the performance of zero shot prompting. And then because it's just a sanity check, I only iterate over 20 rows here. And already I do see some areas of improvement. So for example, here I am looking at the unique values of constituency. It's able to pull out the constituency quite well, and the performance I would say is pretty decent. But there are some areas of improvement. So, for example, it pulls out things like non-constituency member as a constituency name. In actual fact, it is not a constituency name. Um, there were previous iterations when I was iterating on this, where I actually also discovered that when it passed out the name of the MP, sometimes it doesn't, or it neglects passing out the constituent name. So it pass out this as the entire string, when in actual fact it should pass out this as the name, and this one should be the constituency name. So here is where I bring all that learning and areas of improvement into the prompt for few shot prompting. So here I have a few examples that I'm training or guiding the LLM to follow. So in the example of this, like what should our output look like in terms of which one should the name be, which one should the constituency be. Not just name and constituency, but also like name and role. For example, here, this should be the name, this should be the role. And the Speaker of Parliament is a special case where it has three things that we need to parse out: the role, the name, and the constituency. So here, the name itself, I've also constrained or in guide or explicitly told the LLM through this prompt that I want the role to be strictly Mr. with speaker. I don't want it to be all caps. I only want it to be capitalized on the first letter. So we can see that after doing the parsing through the entire data set, performance is even better. We can see that the Speaker of Parliament here is actually reflected as per what I've instructed in the few shot prompt. And we no longer see like non-constituency names when we look at the output. So that's great. Kudos to LLM. Next, how do we then use the data set like this with name of MP, constituency, and then the sitting date to help us understand like for example, the attendance rate of MPs in parliaments in the last 5 years. So that's really the goal of the next section on automated code generation and execution. Given that we already have passed out a structured data set out of purely unstructured text, we then try and explore using the data frame to or asking LLM to help us do some simple analysis based on this data frame. So I find through my iterations and experimentation that in order to do this effectively, we had to be very, very explicit in our prompt. So example, telling the LLM what each pandas column mean, what each row represents, what are some of the key definitions, like what does an elected MP actually mean, how do we look at attendance rate, for example, as well as like the format of the desired output. Just generate lines of code that gives the answer. The final answer should be wrapped with the print function as though we are printing the answer to the console. So with these explicit instructions to the LLM, it's able to generate some basic pandas code for me to answer certain questions. So let's see a few examples in action here. Because we are only using the data frame that we have passed out of the structured output, the context around it is something to do with attendance of MPs and parliament sessions. So Any other questions, this data frame would not contain an answer to that. So the questions here are more in relation to um, questions that the data frame would have answers to. So here, which of the East Coast MPs attended the least parliament sessions? It is able to correctly tell me the name of the MP that attended the least parliament sessions out of all the members of parliament in this constituency. So which of the Sengkang MP attended the most? It's a similar question, and it's also able to, under the hood, generate the Python code that helps to pull out the answer from this data frame. And it's able to correctly do so, with this particular MP being indeed the one that attended the most sitting from Sengkang constituency. Of course, how many parliament sittings were there? This is pretty straightforward. And as well as which MPs attended all parliament sessions. Over the last 5 years, I believe there were 161 sessions. The following MPs are the ones who really attended every single parliament sittings. So that's on automated code generation and execution. And we can see that actually, because its role is basically extracting data and insights from a data frame, there's very little way it can go wrong, unless and of course it's being asked a question that this data frame can't answer. So pretty straightforward here. What's also interesting is looking at like the raw transcribed speeches and trying to generate certain response or output answers based on those speeches. So here is where we apply retrieval augmented generation. It can be broken down into various components. Firstly, we chunk the raw text, and the raw text comes from these parts here that we actually scraped out and then we passed out as one of the columns in the raw data. That's essentially the raw text over here. Ultimately, then we look at the raw text and then we chunk them out into individual chunks before converting the chunks into embeddings. These embeddings are then stored in the vector database ChromaDB. And then once we have a user's query, we vectorize the user's query, and then through similarity search, we find the chunks that are most similar to the user's query, which in other words are the parts of the entire textual database that would be most relevant in answering the user's query. And then finally, we use LLM and prompt engineering to help us look at all the output retrieved relevant information and then formulate a collective response. So I will not go into the details of the individual functions, but here here is where I define the prompt in helping me to find or pull out the relevant information. So I've asked it to explicitly mention the name of the MPs and ministers and the key outcomes of the discussion, and I've asked it to adopt a neutral, objective, and professional tone. So let's look at some sample outputs. Firstly, what were the discussions in Parliament around increasing parent care leave? So here we are asking about parent care leave. The response is telling me about childcare leave. So already we can see that it's not quite answering the question. And in fact, the rest of the answer also not exactly addressing parent care leave. Next, we look at another question. What are discussed about Punggol Digital District? So interestingly, it pulls out like the particular sitting that this part was mentioned, and then it also makes mention about the name of the member of parliament that asked a certain question as well as the response that were given. and it seems to be pretty factually correct, given my mm, limited understanding about this Punggol Digital District. What bills under the Ministry of Home Affairs were discussed in 2024? It talks about various bills. In fact, Ministry of Home Affairs is one of the ministries that, I mean, is the ministry that looks after the homeland security. So obviously, we expect to see bills that were passed in relation to safety and security. That itself is indeed what LLM generated as output answer here as well, and more. So let's look at how then we leverage function calling to kind of bring everything all together. From user's perspective, you can have a variety of questions that are asked, or they might have questions around different things about MPs and issues that were discussed in Parliament. So I think here is really our attempt to kind of push the boundaries a little bit more with LLMs and try and have an overarching approach or methodology to take a user query and then decide what to do with it. So here is what we do to specify the different functions that it could consider calling. So if the user query is in relation to parliamentary information like the sittings, MP's attendance, for example, then you should pass this function. Yeah. Whereas if it's something to do with like the core, the transcribed speeches, and maybe discussions around those issues, then I want the LLM to call this function. But if a query is something has nothing to do with the reports or metadata or attendance records, then give me a polite response to say that I do not know the answer. Right? So here we actually implement function calling, and this is basically the logic under the hood. And ultimately, we see that it should be giving us the same response or similar response to what we've seen above when we did automated code generation as well as RAG. It's giving me similar answer, but sometimes not quite. So for example, we have this question, the same question that was that I run the query on earlier on. It was able to tell me one of the MPs as the name of the MP that attended the least session. Here it tells me that it's not able to give me an answer. So about Punggol Digital District, yeah, it's pretty much covering the same essence of what was covered earlier on as well. Here is a lengthy one. This is pretty big an issue in Singapore. Whenever accidents happen with foreign workers being transported on the open top lorries, there's often mass casualties. So this is a topic of huge discussion in Parliament, and that rightly so, as kind of summarized by the LLM pretty neatly across time. We have 2021, 2023, 2025, and I would say it does a pretty decent job in encapsulating how the discussion has evolved over the years. Another one is this trace together token. It's something that Singapore implemented during the COVID-19 pandemic to mandate Singaporeans to report the location of wherever they go, like a shopping mall, a restaurant, whatever, for the purpose of contact tracing. So what was not made known before the implementation of this initiative was how the data would be used. So it was not made transparent that the data would be exempted from certain laws, and would still be used for in certain use cases like serious criminal investigations. So there was a big issue around this, and discussions in Parliament, and I think the LLM really did justice here to summarize some of the core arguments with respect to this topic. So I can also ask about what issues did particular MP advocate for, and what were the discussions. And interestingly, this is the same question as before, parent care leave, and now it tells me answers pertaining to parental leave, no longer childcare leave. So that really points to perhaps the unpredictability of LLM as well over here, which kind of serves a good segue into the last section here on limitations. I think LLM is at best a language model that's been trained on a certain amount of data with certain knowledge. What we're trying to do here is feeding it with certain additional knowledge base that it probably might not have seen, for it to help us answer certain questions. So there could be limitations around, like, completeness of the data that we are trying to, or the knowledge base that we are trying to feed the LLM on. Certain biases inherently that's accompanied by the way the LLMs are trained. Also, the fact that, like, certain, like, by virtue of the parliamentary records being verbatim transcripts of what's been said, we often lose the nuance, as well as the contextual understanding of the arguments that were put forth in Parliament. So I think that's something that LLM may not be able to fully capture as well. We'll not go into the rest, but I think that really kind of sums up what I wanted to talk about. I think in conclusion, we've explored various methods on taking what we see as highly unstructured data over here, and then going through different steps to achieve different goals. Ultimately, the end goal is to be able to have some sort of QA system, question and answering system, and where users input a question about Parliament, or discussions around Parliament, and then the QA system, in this case what we call AskParliamentSG, providing some answers in response to that question. We still have a long way to go to have a production ready code. I think there's still a lot of prompt engineering that needs to be done, but I think this also highlights the huge potential of LLM in this particular use case like this, where we have a huge amount of knowledge base in text, and trying to be able to make really good sense out of the knowledge base. I think ultimately what I hope we can do is really to bring this to the hands and fingertips of Singaporean voters, and then have them make a judgment for themselves, of course, with certain caveats, and being clear on certain limitations about this tool, and in understanding, like, whether or not a particular MP is capable enough, is effective or will be effective in serving the interests of the citizens. So with that, I've come to the end. Thank you so much for listening. I also would like to take this opportunity to thank the team behind the Google 5 Days Intensive Generative AI course. It's wonderfully crafted. The content is fantastic. The materials are awesome. The whole course is really well structured, and with this Capstone project as a way to force us to apply some of these learnings, it's personally, it's been a huge learning opportunity and experience for me. So thank you so much, everyone. With that, thank you so much, and have a great day ahead.